Okay, hello everyone. We are going to try to do quite a difficult or long and involved linear programming problem. Show you how to do this from beginning to end. All right, so here's the problem. You can maybe pause and read through that carefully, but in the interest of time, I'm going to jump to the solution. And to do that, we are going to go to our apps. And I really love GeoGebra. I'm using this as a Chrome app. You can install that free of charge. It's awesome program, free of bugs, mostly. I am going to just start from the beginning here, and that's what it looks like. I am missing, you can't see all of the tools, but I think that you'll be able to figure it out. Over here is let's see, well, there, I got rid of that. Yep. I'm bringing the scale down for this, and I'm going to move my whole thing down to see as much of it as I can. And all right, so that's just getting this set up. There's an input thing over here. Let's see if maybe I can bring that. Yeah, there we go. All right, that's better. So here's where I can type in my various constraints for this linear programming problem. So I'll go back. Here is the original problem. You can see that it's written just in sort of everyday English paragraph form. I want you to be able to break it down into the individual constraints, and that's partly, just the difficulty of reading through it. But if you go back and look, you'll see that the first constraint is that the combined output of these two varieties of syrup have to be less than $1,000, less than 1,000 quarts per week. Okay, so I've defined my variables. I'm going alphabetically. Amber A is before D, so I'm calling the X's my number of quarts of amber, and my Y's are the number of quarts of the dark and rich maple syrup. The combining is the X plus the Y, and that's less than 1,000. And then the more than 600, same thing, combined, they have to be greater than or equal to 600. Okay, so when I go back to GeoGebra then, I can just type in X plus Y, and then I'm going to graph it as an equality. I think it's easier and clearer to do this, but you can just as easily do inequalities. Maybe another video I'll compare the two, but here's 1,000, and then I hit enter. And oh my goodness, I don't see anything. Well, don't be alarmed. Think about plotting a point. If X is 0, Y is going to be 1,000, and I'm not seeing this here at all. So I need to go to my graphics move and drag this so I see way up to 1,000, and it might take you a couple of reaching up, and look at how the arrow, it goes from across to an arrow. Pull that down till I see 1,000, and it should come into view. There it is. And now I just need to do the same thing here. You can also do this by zooming out. I feel as though this is a little bit easier. All right, so then I'm going to do this. X plus Y equals 600. That's the boundary that I need to be above. Okay, so less than 1,000, try a test point like the origin. 0 plus 0 is less than 1,000, so I can shade towards the origin. This is the greater than 600, so if I plugged in the origin 0, 0, it would be wrong, so I will shade away from my wrong test point that way. I go back to my constraints. You cannot make more than 700 quarts of either type of syrup. Okay, and then if I go to that, then I'll just say that X equals 700 and Y equals 700. These are my other two boundaries, and I'm going to be less than that. So my diagonal zone is now being shaved off a little bit. Then going back to the key, you can see that this next one is a little bit more difficult. It takes more fuel to boil off the water. When you cook the maple tree sap, cook it down, boil off the water. It takes more energy to get the dark variety. And in fact, it takes 0.4 kilograms of wood pellets to burn off 1 quart of the dark, to make 1 quart of the dark, and half that to make the amber. And the total fuel budget allows only 333 kilograms. So you simply write that out, that for every X, and remember to assign your variables, and there's no guarantee that they're always going to be given to you in terms of X and Y. So the D, the Y value is given first. Just make sure you match up the 0.4 with the y's, the 0.2 with the x's. And now we're going to type this constraint into our key here, into our GeoGebra. So 0.2, I don't need the 0x, plus 0.4y is equal to 330, and then I'm going to be less than that. We have to be below our food budget, our fuel budget, and so this is this constraint right here. Okay, so it's slicing off just the top corner of that. Going back to the answer key, here's the next constraint. The two types of syrups have to be filtered and purified. Amber takes 10 minutes in the purifier. The dark takes 5 minutes, so it's easier to purify. Maybe you wouldn't expect that to be true in real life, but who knows? And you've got 7,000 minutes. All right, so it's not given to you in hours. That would make this problem a little bit more tedious if that was given to you in like 16 hours or something like that, but it's all in minutes. So I'm going to type that in exactly as it appears. 10x, 5y. Oops, made a mistake. That's not 7, that's y. And when I hit enter, you can see that it does simplifying, right? So you shouldn't be alarmed by that. That's just GeoGebra simplifying. Now here I'm slicing off another bit of it there, and I'm going to go back to my answer key, and there is more demand for the dark and rich, so the y values will always be bigger than the x values. Okay, that is a separate constraint from the one that follows it. So I go here, and again, I'm going to do y equals x, and y is greater than x means that I'm going to shade above this. The y values are bigger, and this is in the y direction for my boundary line. Again, you could try a test point in here. Try 200, 600. Is 600 less or greater than 200? Yes, it is, so I'd shade in the direction of my test point. And then my final constraint is that you know from experience that dark, even though it's more popular, is less than 4 times as popular. So there it is, y is less than 4 times the amount of x's, 4 x's. y equals 4x, and I graph that, and I'm shading less than. All right, so now what I do is I'm going to find that feasible region. Well, as we've been fencing off, you're paying attention to where those boundaries are and which side you're shading in. It's this point and this point, and as long as I get close, GeoGebra is clever enough that it'll know to snap to the intersection. So this then is my feasible region. These vertices are the only real solutions, and there's no constraint saying it has to be whole numbers, so we're allowing decimal fractions of the quartz. I don't like these extra lines being labeled. You can click and hide anything you don't like. Oops, I like the polygon, I just don't like the lines being labeled. And now I can see where the vertices are, because when I click on them, I'm given these points right here. So this is the critical thing. Notice that point B there is 175, 700. C right here is 250, 700, and so on. D is 350, 650. I could solve these algebraically, and I would set the equations equal. I would use like Gaussian elimination, and I could solve for those points, but this is the nice thing about GeoGebra is it does that for you. Then I simply need to go back to my objective. What is my objective? I want to make as much money as possible here. I make $8 for every amber quart sold. I make $9.50 for every dark and rich quart of maple syrup that I sell. That'll make my total earnings. So I take each of those vertices, each of the coordinate pairs, and plug them in, the x value and the y value, and I see what happens after that. So I did that in advance of this, and this is, and this is it right here. And I'll try to drag that in so you can see it a little bit better. But plugging in, there's the 400, 600 coordinate. There's the 200, 700 coordinate. It's this one here, the 350, 650, that gives me the very best level of earnings, $8,975. All right. The final question had to do with, well, if you need to shut down operation and still try to make as much money as possible, which vertex down here, A or E, would be better? Well, you make a little bit more money for the Y's, so the higher Y value here at point A would be the better one for that. And I'll let you do the calculation. That's it for me. Thanks very much.